Welcome to today's lesson. Okay, before starting, I wanted to make some announcements. So as you saw in the group, I did the poll to understand what do we want to do with my midterm assignment, and basically everyone agreed with using the midterm assignment as a bonus for the exam. So we will leave it that way. So now it is not the 5 points I've said before, but it is 3 points that will be added to the final grade of the exam, okay? Is it clear for everyone? Yeah.
The 3 points is added on top of the past grade.
On top of?
On top
Of the 30 points that you can get on the exam, on top of that, you might get 3 points.
Okay, but for example, if you get 15 on the exam, will that apply?
Yeah. Yeah.
Okay.
But let's hope no one gets 15.
But that means it can help to pass.
Yeah, it might help to pass. Yeah, sure. Any questions on the midterm assignment? Is it clear for everyone? Okay, so I think I will be, because I haven't already updated the text of the midterm assignment, but I will update the text and then I will send a message to make it official that now it is 3 points on top of the exam, okay? When is the deadline? 18 May. At midnight, okay? Okay, so that. Okay. Have all of you tried already to configure and to deal with the GitHub Classroom? Is it working? Okay. Were you able to clone the repository? Okay. So my advice is also, if you could clone the repository, make some silly modification and try to push a modification, and let's see if everything works, okay? So to be completely sure that everything is working and that at the end or near the deadline, you don't find out that something isn't working. So my advice is try to do it now. And if you have any inconvenience, you can use the lab or you can tell me through Telegram so we can fix it early. And okay. Nice. So okay, so last week we were talking about the forms, and now we know how to submit data from the user to the server, okay? There is just one thing with what we are doing now, and it is that the data stays there until the application closes, okay? When we stop the application and when we rerun the application again, all the data that we have stored is lost. Why? Because that data is saved into the Flask application. So it is basically data that has been saved in memory. Okay? And we obviously don't want that for our web application. We want the data to persist, the data to stay there for all of the users. Okay? So that's why now we are moving to the database. That is the module or the part of the application that is responsible for storing the data, for retrieving the data, for dealing with the data. Okay, let's check. So we will understand in the context of a web application how to make the data persistent, and not just persistent, but available for all of the users. Because don't forget that here, when we talk about a web application, it's not an application used by a single user, but it's an application that is used by hundreds of thousands of users at the same time. So it's a distributed application, and we need to have a central point where all of the information is stored. We will see how can we manage large data sets beyond the in-memory storage. That is the one that we are using right now. And we will use SQL to do and to perform the queries over that data. Okay? I don't know if you tried to solve like the last lab that was dealing with forms and trying to save things with forms. And I don't know if you notice, but for instance, when I ask you this requirement of saving the post associated to a user, it became complex, difficult, hard to figure out where were you going to save those posts. If you were going to link those posts to a specific user, if you were going to save like a different list with the post and a different list with the users, how were you going to point with the ID to the ID of the user? So it's kind of difficult to manage in that way with the Python dictionaries. So also in this case, the database is a software module that is already optimized and that it has been think and designed in such a way that storing data there and retrieving data there is so much structured and organized and standardized, okay? And all of that is possible through SQL, okay? So once again, always in our architecture slide, what we are doing is shifting from the from Flask, where we had like the application server, we are shifting to here, to SQL. That is the component responsible for storing the data, for retrieving the data, and so on. Okay. So as we have said before, it is a system that stores and organizes data, making easy to retrieve, manage, and update the data that our application will be dealing with. This is super important because it ensures integrity, security, and performance of an structuring table, rows, and columns. And as you know, and as you have told me, that you have already some experience and some familiarity with SQL. That is the language that we will use to store things, to retrieve things, and to deal with the data. Why do you think this data integrity is particularly important in this context of a distributed web application? Here we must consider once again the case in which thousands of users are doing things on the same data structure, on the same data repository, on the same data container. No? So we need that if two users are doing at the same time, for instance, a booking or a reservation into a specific service, we need to make sure that the software that we have under that the database manager that we have under that is able to manage that two requests in a consistent way. Okay? What would happen if instead of using a database, we try to implement by ourselves, and in our own implementation, two users are able to do the reservation at the same time? Then it will crash. Or if two users can do the same payment for the same thing at the same time, it would crash. So what is important about the database is that it's a specific software module that is able to guarantee us some kind of integrity and some kind of safeness with how the data is being managed and with how the data will be structured, let's say. Okay, so I don't know if other than the relational databases you have dealt with non-relational databases, or if you have heard about non-relational databases. Do you all know what a relational database is? Okay, what is more or less a relational database? Yeah. Yeah, it's like a kind of database in which the data is represented basically as tables with rows, with columns, and in which the relations are done through a specific attribute of a row. No? So we all know, or maybe we are all familiar with a primary key, what a primary key is, how a primary key works, with a foreign key also. That is the way to link two rows belonging to different tables. And yeah, it's basically a representation, a way to structure the data, basically using tables with rows and columns. Here, what does each table represent? It represents an entity. What is an entity? An entity is an instance or some actor or some portion of information that we want to represent in our application. What does it depend on? It depends on the application that we are trying to implement. So if, for instance, we think of the application of the music festival, we could think of as an entity there as the users or the artists or the performances. Those could be entities for that specific text. If the application would be about, well, I don't know, managing reservations for a gym, we could think of the entities as the trainers or as the users or as the time slots or things like that. So the entity, basically, the entities of a specific database basically depends on the requirements and depends on the specific web application that we are trying to implement. Then we will see how to get the text and do all of the process of designing a web application. And one of the first things that we are going to use before starting to code and before starting to do everything is to map all of the requirements and to try to identify which are the specific entities that are involved in the text, and from that we can build the whole application. Okay, this is just a reminder, but maybe you already knew this, that all of the tables are always named in plural, okay? And it makes sense because we know that the contents in the table represent all of the instances of a specific entity, okay? Well, just a random question. When you think of implementing a web application, where would you start to implement the web application? Top down or bottom up? If I ask you to try to implement an application and having in mind this schema, would you start implementing it from here up to here, up to the front end, or the opposite, the front end to the back end? Who would say bottom up? Why?
Because the structure and the architecture for the application should be defined first before making the front end.
Okay, yeah, but why should it be defined first?
Because I think if we define the front end first and then we change the structure, it could be more difficult.
Yeah, basically because of that. If we design a database, but we forget to represent an entity in the database, or we don't take into account how to fulfill a specific requirements with the data that we are storing in the database, or we forget to represent a relation between entities in the database, and we have already built all of the application built upon a wrong database structure or upon a wrong database design, then fixing that basically represents doing everything from scratch again, okay? If instead it is the opposite, fixing an error here in the front end is less painful, okay? If we forgot to add a new button, if we forgot to add a new field to a form, if we forgot to do something here in the front end, it's easy to solve. But if we forget something here, and on top of this, we have already built our server application, and on top of this, we have already designed our routes and the interaction with the user, fixing something here means touching all of these components. So ideally, we have, and my advice is this one, for the exam and also for the live, spend a lot of time designing the database and spend a lot of time understanding and trying to map and trying to understand which are the entities, which are the relations, how are you going to represent the entities, and always work with a bottom-up approach, okay? We will get onto that when we will see how to implement the web application, the final exam, but just to make a reminder on that. Okay, and the tables can be linked through relationships that are the foreign keys. I think you are familiar with the concept. And with SQL, we have the option to do powerful queries or all of the data that has been stored in the database, okay? Just to Here, if I show you this structure, what can we infer from this database? What is this database about, and how does it work? What is like the main entity here? Do you agree that is the person, right? So it's basically a database that enables us to represent people, persons in there. And then what is these friendships? It's basically a way to represent that two persons can be friends, okay? How do we achieve this? We achieve this through the foreign key. That this foreign key is basically a value pointing to the ID of the person entity, representing that a friendship is composed by two people, by two persons, okay? Then what do we represent for each person? We represent that a person has a gender, and in this case, the information we need to represent for a gender is just its name, and then each person has a location, okay? So we might, just from trying to understand this database, we might infer that this database should be for something like a social network or something like that, no? In which we want to represent users, and in which we want to represent relationships of friendship between the users that we are storing in the database, okay? Nice. And then, I don't know if have you ever heard about these ACID properties in the database course? What is it? It is like some basic properties that a database systems guarantees us, so that we don't have to deal with the complexity of guaranteeing or implementing these properties, but it's something that by default we can expect from the database system. So which are these properties? Atomicity, consistency, isolation, and durability. So atomicity is all of nothing. If a transaction starts but it can't finish, then the transaction is completely cancelled. So if I try to buy the tickets and by the end I couldn't buy the tickets because some condition was not met, I can be sure that all of that transaction was cancelled, okay? I'm thinking of an example like, for instance, buying a ticket is a transaction that has like intermediate steps, such as finding available seats and seeing if the user has no previous reservations, and then if both of those conditions meet, then the tickets will be booked. Okay, so let's suppose that we have like a query that makes those assessments in order to make sure that it can buy the tickets. So this property basically says us if all of the conditions were not met and the transaction could not reach like the final point, then we can be sure that nothing will be done, okay? So that all of the transaction will be canceled and that the state of the database will remain consistent, no? So that it won't make like temporary modifications to the data and that the data will remain dirty, but all of the data will remain consistent and all of the transaction will be canceled. Then the consistency, that the data must stay correct before and after a transaction. Then the isolation, that in our case for a distributed web application is fundamental, and it's the fact that the transactions don't mess with each other, so that if we have two users at the same time trying to book something, the transactions, for one of him, the transaction will be done, and the database and the data will remain consistent, and for the other, the transaction will be blocked by the system. And in any case, we can be sure that all of the states will remain consistent. And the durability, that is, that once the data is saved, we can be sure that the data will stay there, that we won't lose the data, okay? So this is one of the reasons why we use a database system, because it's a system that has already been built, that is consistent, that is strong, and that ensures us these properties that we need for our specific application. And I don't know if you have heard about non-relational databases, or if you have worked with non-relational databases. So non-relational databases are the opposite of relational databases in the sense that they are not so structured, they are not so fixed, but they are more flexible, more dynamic. Okay, so they store the data in flexible formats like documents, and in this case, I don't know if you have heard about this MongoDB, that is a specific or a very famous non-relational database, in which the entities or the records of the data are saved into documents, basically. Okay, like JSON documents. Okay, so it is not anymore a table with the fields, with the columns, with the rows, but it is a JSON document in which the data is saved. Some other work with key value pairs, so it saves the data not in a document, not in tables, but with they represent the data with a key and a value. So for a specific key, it saves a value. Okay, and then we have graphs. Okay, so here, for instance, we have an example of how would a relational database look and how a non-relational database look. So as you can see here in the non-relational database, it saves the information as a JSON, representing all of the same data with this structure. Why do you think we would want to use a non-relational database? Yeah. Any clue? Because, I mean, if I ask you to choose between these two, relational and non-relational, which one would you choose? Which one do you like more between these two representations? The relational? Yeah, this one seems more structured, more ordered, more consistent. Yeah, so we would say the relational one. So why do you think this one exists? Yeah. Which one, the relational or the? Both, I don't know, maybe not, because here in the relational one, we know that below it works with algebra and all of the indexes are specifically designed so all of the queries can be solved super quickly. So maybe I would say the relational is more optimized for the queries. But I agree that this one could be faster for the development, no? So, for instance, consider that with the relational database, we have to design everything up front, okay? So when we are trying to build something with a relational database, we already design all of the database. We already have to identify all of the entities. We have to identify which are going to be the fields that we are going to set for each entity. We have to identify upfront all of the relations between the entities. And sometimes in real life, it is not possible because what we design one day might change the day after, or the requirements might change. Or if we try to think in a platform that we are building today, maybe tomorrow we will have different features we want to add, different challenges, different functionalities. So sometimes the data has to evolve. So in the case of the relational databases, making that very rigid structure to evolve is more challenging than in here. Because here you can see that for each of the entities, if we, for instance, for the second entity, let's say now in our application, other than the name and the surname, we also want to store the email of the user. So what does that change would require in this case? Adding a new field in the JSON for each entity that enables us to store also the email of the user. So in this one, evolving is super easy. Doing changes on the data structure, or adding fields or adding information is super easy. So this one, the non-relational, doesn't require a fixed schema, making it ideal for unstructured or evolving data. Okay. We must also consider that not all of the data that our application will be dealing with is critical data. Okay. So we must keep, for instance, consistency for some specific things, but for some other things, the data could be more, it doesn't have to be transactional of all of the data of our application, okay? So in that case, mixing also a non-relational approach would be feasible or would be an option to represent data that doesn't have to be data related to transactional operations of our application. So, well. And this one is common in real-time applications, the non-relational data, okay? Of course, this is out of the scope of the course. So in the course, we will just focus on relational database. But I just mentioned this because in web applications, in real life, it's also common to use non-relational databases. So if any day you will be working with a web application and you are dealing with selecting which technologies you are going to use in the stack or which data management is more convenient for you, it's good also to know that not all of the backend and not all of the database management can be done through relational databases, but that there is that there is also the option of non-relational databases that basically work like this. Once again, the course that you have already seen on databases, which one is that? You already took a course, right?
Yes.
Okay. That is?
Introduction to Databases.
Okay.
Last year.
Okay. And what is it basically about? It is SQL. Okay. Okay. No non-relational databases. No.
Just like the project of the database and then the building.
Okay. 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 What was the project? In that?
Like the design of the schema.
Ah, okay. 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 And queries on top of that, I suppose. I mean, doing queries on top of the schema that you have designed.
Yes.
Okay. Okay. And which database did you use in that time?
We used something from Oracle, Apex, I think it was called.
Okay. Okay. Fine. Thank you. So in this case, we will be using SQLite. That is super flexible and super convenient for this course because in SQLite, basically, the database is stored as a file, okay? So as you will see here, it is a relational database. It applies all of the SQL rules. It applies everything like the same things that would apply for a database running into a remote server, but in this case, we will represent everything into a single file, okay? So it stores basically all of the data in a single file on the disk. It is commonly used in mobile applications and embedded systems and for rapid prototyping. That is basically what we are doing here. Anyway, as I will show you later, the way we are going to implement the things gives us the flexibility and the consistency that if at any moment we want to connect our web application with a different database, we just have to change some parameters and we will be able to connect to any other database, but we will get to that. And the reason we choose this specific SQLite for the course, it requires zero configuration. So it's super easy to configure, it's super easy to integrate into a project, and it doesn't require a separate server or complex setup required, okay? Okay, so here in the slides, I prepared like a step by step on how to first to set up the database and how to deal with SQLite, and then we will see how to connect all of this with Flask. That is what we have built so far. So if you want, we can now start working on how to from Python connect with database, and then we can see how to connect all of this or how to integrate this with the Flask. So the first step in a Python application is basically to import SQLite 3. So well, if you want, let's try to do it directly here. Basta. Okay, please. Okay. So the first step, basically, I've created here a Python application. And the first step is just to import SQLite, okay? So that we can deal with SQLite 3-like files. Then we will use here, we will declare like a variable here in which we will store the query that we want to execute against our database, or the query that we want to execute on our database. How do we typically implement this? Well, basically with a variable, with a string here, and in the string we basically write the query that we are trying to execute. In this case, this is just an example. I'm doing a select ID original modified from the translation table. So from the translation, I want to get the fields, or the fields ID and the field ID original and modified. Okay, so it is basically a string. What do you think is the difference between the first one and the second one? That the first one somehow is static, no? So just with a string, we can define or declare what we want. In the second one, instead, it is like if it had parameters, no? So insert into translation, and I'm not explicitly saying what do I want to add here, but I'm using placeholders, okay? So if the query includes variable parameters, use placeholders. This is important. We never build the SQL queries by using concatenation or by joining strings. So if, for instance, this original has the value that I want to add, I would never use a string insert into translation plus original plus modified. I mean, we never try to compose the string. We always use this approach of the placeholders, okay? And instead of joining the strings, we always use the SQL template with placeholders. And finally, then we execute the application. So let me check here. Super important, I have forgot this. How to deal with or how to create the database SQLite files. We will have this very simple program that is called DB browser. This one, SQLite browser, okay? So it is a super simple application that enables us to create the files or to create the database files. Okay, so if you open this, it's kind of ugly and it's somehow difficult to use, but it's simple. So for our purposes, it's fine. And it doesn't require any configuration, and well, it's easy to use. So here I will ask you to install this on your computers. Because, well, as you can see, it enables us to create and compact database files, create, define, and modify and delete tables, and basically all of the operations through this graphical interface. Okay, so for creating our database, we will use this DB browser for SQLite. Okay. Once you have installed that, you will see something like this. I'm sorry, because here I can't. No, the interface is so simple that it doesn't enable to zoom in on the graphical interface. But okay, I'll tell you what I'm doing here. There is the button New Database. So what I will do is to create a new database that I will store in the repository. Okay, and it has created my database. So first of all, the overall entity is the database. And once we have created the database, we can start adding tables to that database we have created. I don't have in mind any example. I don't know. Let's create a table with users. That is like the typical example. That we create a table with users in which we save the ID, the username, the user or the email, the name, and the surname. Okay. Just for the sake of this example, we will create a table with users. How are we going to name our table? User or users? Users, because it is always plural, so we will call this users. And which fields are we going to add to a table? From the database course, what is the field that you have always to add to any table? The ID. That is the primary key. That it is always a numerical value, and it is always an auto-increment value. Okay, do you know what I'm referring to, right? And do we agree all with this? Okay, so please take this into account, because in the exam it usually happens that many people created like or use the primary key with a different attribute, and we already all know that that's not the optimal way of doing that. I mean, I can't say, since the email is unique for all of the records, then I will use the email as the primary key. Okay? We always, by default, create a column that is a numerical column, that is an auto-increment column, that we set that one as the primary key. Okay? So, ID, this one is integer, this one is not null. Okay, and here, with these specific options, you can set the properties for each specific field. So in this case, the NN stands for not null. This one, CP, stands for primary key. This one, AI, is for auto increment, and this one is for unique. Okay. Here I'm selecting all of them, but as we already know from the database course, if I had just said primary key, it implies that all of the other options have to be filled, no? Because if I have a primary key, then it can't be null. If I have a primary key, okay, no, the auto increment, we must set it ourselves. But if we have a primary key, it also implies that that specific field is unique, okay? So we could have left this as CP and AI, but okay, it's fine if we add all of them, okay? So we have the ID. What else are we going to represent for our users? The name, for sure. And in this case, it's not anymore an integer, but a text. Are we going to leave the option or optional the name of the user? No. We typically want that if someone registers in our application, at least he should give us his name. Then we have the surname. What else can we represent for a user? The age, yeah, maybe the age. Nice, yeah. So a good example. How do we store the age? With them? Okay, and how do you imagine that age in the table would look like? Like 21 or 22 or something like that? I mean, what do you think specifically what would be the data saved into the database in that case? For instance, if I think of a user, okay, Juan Sáenz, Juan.Sáenz at Polito, that's it, and the age, what do you think would be the specific data saved there? Like the number? Okay, and what happens next year when I won't have that age anymore? How are we going to deal with that? Because if, for instance, in the registration, I ask for the user, give me your age as a number, as a specific number, and I set the age, then how is the database or how is the application going to know the only thing with that information that you can be sure of is that by April 20, I had that age anymore. No, you can't know anything else about me. So, well, yeah, in that case, we must think of a way to effectively know not just the age of the user at the moment of the registration, but also a way that ensures us that we will know the age of the user at any moment. So instead of the age, the date of birth, okay? So yeah, that's why all of the websites don't ask for the age, but they ask for the date of birth. Okay, so birth. And do we all agree that we are going to save this as a text? Yeah, because basically the date of birth is a representation that we can map into a text. Yeah.
Why is the main integer?
Because I haven't seen this text. Okay. And we are going to say not null. Okay. So here, as you, well, for sure you can see, but we have already our table, okay? That is users. Below we have a different table, that is a table that the programs create by default, but it is for operational tasks. So this one, we never touch this one, but we have our tables in here. So we have so far created just users. And back to our application, you can see that here we have example DB. Okay. If I click here on example DB, okay, if I click here on example DB, you won't see this because you haven't installed a specific extension that I will just show you. But we can see here from Visual Studio Code that we have our table users, that it has these specific fields. Okay. And if we don't have any rows, but if we had rows, we can explore also the data that has been added to that specific table. What is the most important thing that I want to make you aware of is that here our database is represented as a file. Okay. Okay. Once again, the same thing that I have been telling you all of these weeks and insisting you all of these weeks. Of course, since we are learning how to implement the application and how to deal with the application, we are doing everything locally. Okay. So everything is running local in our computer. But we must not lose the sight on the fact that in real life, all of these components would be in remote servers. Okay? So in real life, a web application, you don't execute a web application in your computer. The web application is deployed remotely. So the web server is in one server remotely that you can access through an HTTP request, as the ones that we do from the browser. The database is typically saved also into a different remote server that the web server connects to. Okay, so here we have everything inside one folder, but let's have in mind that in real life we are doing this for the sake of learning and for the development, but then in the deployment everything will be on different infrastructure. Okay, so we have already the example database, and okay, and in order to visualize the database as I'm visualizing right now, you have to install this extension in Visual Studio Code. That is called SQLite Viewer. And once you have installed SQLite Viewer, you can open these files and visualize them in this way. Okay. Okay, so up to now in our project we have these two files, the one that represents, or the one in which we will implement the integration with the database, and the database. Okay. Let's continue with the slides. Okay, so let me. Okay, so far, what did I do? I just created a string that will represent me a query that I want to execute on the database. In this query, what do I want to do? To insert into a user's a new record for specifying the username, surname, email, and birth date. Why all of these fields? Because if you remember, when we created the database, we said that all of these fields had to be non-null. So these are required fields. So we must add a value for all of the fields that we, at least for all of the fields that we declared as non-null. Which one are we missing here? Which field? The ID. Why do I don't include the ID here? Because it's auto increment, so it's a property that I have that the database will manage by itself. So here I never indicate explicitly the ID because we already know that it's something that the database will manage, and it will manage in the most optimal way because it will auto increment the previous one. So we don't have to do that kind of stuff to see what was the last ID so that we add one and then we pass that ID. No, we leave that responsibility for the database that is specifically designed and that can ensure us all of the properties we have seen before, the ACID properties. So in that specific field, in that specific case, we don't have to indicate that field. Okay, I will write the code and then we will get back to the slides so that we can go a little bit. Okay, I just wrote it like in different rows, so to make completely clear what it's happening here, but I think it's pretty self-explanatory what we are trying to do, no? So first of all, we define the query that we are going to execute or that we want to execute. That is this one. Insert into a table a new row for a specific user. But here, as you can see, we use placeholders because they are not fixed values that we can define already in the query, but are values that we will define later dynamically when we are going to execute this query. Okay. What is the way of defining the placeholders? With this question mark character. Okay. So this one would be written as insert into users into these specific fields of the users table, the values that I will indicate you later. Then what is this for? Well, for connecting with the database. Okay. The same as probably you have done with the database you have used in the course. We must always first connect with the database so that we have a connection, a communication with the database, and that we can make changes on that specific database. Then we get a cursor. I don't know if you're familiar with this cursor concept. That is like a pointer to the database, like a handle with the database. Like the connection is represented by this cursor. So we get this cursor, and then over this cursor entity, we execute the query. Okay. So this SQL stands for the query that we have defined here. That indeed SQL is not very. Let's call this my query. And in this case, where we had this query with the placeholders, when we execute that query, we have to define or to indicate which are going to be the values that we are going to pass for the placeholders that we have defined above. So if you take a look here, you can observe that we have 4 placeholders. And here, when we try to execute this query, we have to pass 4 parameters. Okay. So we pass the name, the surname, the email, and the birth date. Then this is basically a copy paste. And then we do the commit of the transaction, and then we close first the cursor, that is like the handling or the reference that we are having to the database, and finally we close the connection with the database. Okay. So first we connect. Then we get like the cursor, the reference, or the pointer to the database. We execute the query, and then we do the opposite. We first close the cursor, and then we close the connection. Commit, close the cursor, close the connection. Clear? Mm. Let me check something. Yeah.
I think the problem is because you don't use the complete path of the database.
Okay, because
And
in
I think the system, the library, uses this one, database, not
which one?
the external, not the database in 8DB.
You mean this one?
Yeah, yes.
Yeah, I might have saved two databases.
You put in
Let me
the Python file the complete path, but it works.
delete this one. Okay, well, let me check something. But I don't know, it's because in your case, instead of setting example, did you change something here? No,
I put it to the complete path and it works for me.
the complete path for this database.
For the database.
But well, no, but this one, I mean, should not be the issue because anyway, the file is within the same folder. And are you executing the app from this folder or are you executing?
I tried both way and I have only one database and it works for one side and the other.
Okay. Well, let me check something. No, because this one should be, no, because if always we have to specify like the whole path, okay, it would work, but it might be kind of ugly to work that in that way. Let me check some. No, because here, what I'm seeing is that it has like erased like the table. The table is not anymore here. Let me. Yeah, it has erased the table, so well, users. Okay, in this case it worked. Well, I will check this because I'm kind of concerned. I mean, as I told you, SQL browser is not super nice, so sometimes it makes inconsistencies. And well, my advice is maybe try to edit the file with SQLite browser, then close it so that two processes on your computer are not at the same time working on the same resource, that is the database file. And then once you close that, you open from Visual Studio Code and it should work. Because here, what I kind of identify right now is that I created the file with SQLite browser, but then I try to execute and to access that specific resource from Visual Studio Code, and somehow Visual Studio Code overwrote what I did. So the error that I was being shown is that the users table didn't exist. So somehow I think it overwrite the file. So okay, the advice is first create the database with the SQLite browser, then save, close it, and then work just from Visual Studio Code. So that two programs at the same time are not trying to access the same resource. And when we do that, okay, I executed this small program that was the one to connect to execute this specific query with these parameters and close. And if I come here and I update the tables, then I can see that the new record has been added here. No? So that now in the users table, we have a first row with the, as you can see, I didn't specify any ID, but the SQLite and the database manager by itself added this ID as an auto increment, so it starts with 1, with the name that I specified, with the surname I specified, with the email, and with the birth date. Okay. So the message here is that each time that we will want to interact with the database, we basically follow this recipe that I've shown here in this tiny program. Okay, so it's like a sequence of steps that we follow. It's almost a copy paste, and with that we should be fine. The other message is that here we will work with SQLite 3, and with SQLite 3 a database is represented into a single file, so it's super simple to reference. And well, we're done. Do you have any questions? Yeah.
Could you explain again this concept of a cursor? Like, how can you think about it?
We can think that first we make the connection with the database so that we know that there is like a direct communication with the database entity or with the database server. And then the cursor is like, this idea of cursor has sense if we think that a database can be accessed at the same time by several users, no? So that you give each user of the database that in that moment could be connected like a reference to your tables, like you try to manage them, try to give them a pointer to the resources that they might be modifying. Okay.
We only need one connection in that case.
Yeah, we open one connection and we have one cursor. So let's say the connection is the communication, and the cursor is like a handle to the resources that we have within that connection.
So for one connection could be multiple cursors.
Yeah, but typically the good practice is one cursor for each connection. Okay? So the good practice is for each user, for each request user that will be doing requests to a table, we create the connection, and within the connection we create the cursor. Okay? Yeah. It's like the word for that it's closer to cursor is a session, like a session that the user creates within that connection with the database. So we can think of a cursor as a session that the user has on that specific connection.
And if every time you make a new connection, then the connection is already like a session.
No, because here you close the connection. After you execute the query, you close the connection with the database.
Yeah, so I mean, it seems to be like the same in terms of the connection and the cursor.
But the cursor happens within the connection. It's a session within the connection. Yeah. Yeah, yeah. Because anyway, the requests that we are doing are transient requests, like very specific queries that we are doing to get information, to set information, but we don't keep for each user a connection because that consumes resources. Okay. Okay, fine. So see you tomorrow.